Somewhere in our galaxy right now, there is an object the size of a city, 20 kilometers wide. You could drive across it in 15 minutes, and it outweighs the sun. Not matches, not rivals. Outweighs. 1 teaspoon of its material would weigh 1 billion tons on Earth. That is not a typo. 1 teaspoon, 1 billion tons. It is called a neutron star, and it is the most extreme object in the universe that still has a surface. So, what happens if you fall into one? Welcome to What If Universe, where one question can change everything. And today, we are falling into the densest place in the known universe. To understand what kills you, you first need to understand what you're falling into. A neutron star is not a star in the way you imagine a star. It does not burn. It does not fuse. It is what is left after a star dies. When a star 10 to 20 times the size of our sun runs out of fuel, it does not go quietly. It collapses completely, leaving nothing. In less than a second, the entire core, billions of tons of matter, falls inward. The pressure becomes so incomprehensibly extreme that electrons and protons get crushed into each other, forced together, merged. What comes out the other side are neutrons, pure, tightly packed neutrons, squeezed together until they cannot be squeezed further. The result is roughly the mass of the sun packed into a sphere 20 kilometers across. The sun is 1.4 million kilometers wide. A neutron star is the same mass, in something smaller than most cities. The neutron star's magnetic field is the first thing that finds you. On Earth, our magnetic field measures around half a Gauss. A neutron star's magnetic field reaches 1 quadrillion Gauss, 1,000 trillion times stronger than Earth's. When a magnetic field reaches around 500,000 Gauss, it begins to distort the shape of atoms themselves. You crossed that threshold a long time ago. Every atom in your body is being pulled in a slightly different direction. The surface temperature of a neutron star reaches 1 million degrees Celsius. So hot, it does not glow in visible light. It glows in X-rays. Right now, it is bathing you in radiation that no human body was built to survive. But none of this is what actually kills you first. The closer you fall, the more you feel it. A pull. Your feet, being closer to the neutron star, are being pulled significantly harder than your head. This difference in gravitational force across the length of your body is called a tidal force, and near a neutron star, those tidal forces are 200 billion times stronger than Earth's gravity. Scientists have a name for what happens next. Spaghettification. You are stretched, lengthwise, pulled thinner and thinner. Feet accelerating ahead, head dragged behind. If you fell from just 1 meter above the surface, you would hit the ground at 1,400 kilometers per second, not per hour, per second. The tidal forces alone would tear you apart before you ever arrived. But let's say you survived, because the things waiting below are stranger than the fall. The surface of a neutron star is perfectly smooth. Not smooth the way glass is smooth. Smooth the way physics demands. Any surface feature taller than 5 millimeters collapses immediately under its own weight. The gravity here is 100 billion times stronger than Earth's. Even the smallest imperfection is crushed flat in an instant. Beneath your feet, if you could stand, is a crust of iron nuclei locked into a rigid crystal lattice. 10 billion times stronger than steel. And it is just the beginning. Descend further, past the outer crust, and you enter something that should not exist. A layer so strange that physicists had to name it after food just to describe it. Nuclear pasta. At this depth, the pressure becomes so extreme that neutrons are no longer behaving like individual particles. They are being squeezed into shapes, flat sheets, like lasagna, long tubes, like spaghetti, tangled blobs, like gnocchi. This is what the mathematics predicts, confirmed by simulation. Nuclear pasta is considered the strongest known material in the universe, and you are still not at the center. The core of a neutron star is the most mysterious place in the universe. Scientists do not know what lives here. The conditions are so extreme, so far beyond anything we can recreate, that the physics we rely on breaks down. Some physicists believe the neutrons themselves break apart here into their most fundamental components. Quarks, raw quarks, not bound inside atoms, not trapped inside neutrons, just free. A state of matter called quark-gluon plasma, the same state that existed in the first microseconds after the Big Bang. If this is true, the core of a neutron star is the closest thing to the birth of the universe that currently exists, and we cannot confirm it. There is one more thing happening here. Something Einstein predicted. Something most people never think about. Time is moving differently. Extreme gravity does not just crush matter, it slows time itself. This is general relativity, tested, confirmed, and built into the GPS satellites orbiting Earth right now. On the surface of a neutron star, for every 10 years that pass on Earth, only 8 years pass here. 2 years. Erased. By gravity alone. Stand on a neutron star for what feels like 80 years of your life. And a century has passed back home. Everyone you knew. Everything you left behind. 100 years older. The neutron star does not just destroy the matter that falls into it. It bends time around it. So here is where we land. The magnetic field begins dismantling your atoms long before you arrive. Tidal forces stretch you apart before you reach the surface. Below that, the hardest material in the universe. Below that, nuclear pasta. Below that, a core science cannot explain. And underneath all of it, time itself running slower than anywhere else on Earth. We will not fall into a neutron star in our lifetimes. But there are an estimated 1 billion neutron stars in the Milky Way alone. Silent, dark, invisible to us. Every single one of them was once a star, burning for millions of years. And then, in less than a second, it became something denser, stranger, and more violent than anything it was in life. The universe doesn't warn you. It doesn't slow down. It just keeps making things we cannot survive. Because out there are objects that delete light, forces that reshape galaxies, and questions that make this one look small. This is What If Universe. And we've barely scratched the surface. See you in the next one.